Now, in the next example, what we find, AB is a vector in two-dimensional plane. When we say AB is a vector in two-dimensional plane, then point A and B have coordinates like x1, y1 and x2, y2. This is what is the meaning of vector in two-dimensional plane with magnitude 4 units, making an angle of 60 degrees with x-axis and lying in the first quadrant. Find the components of AB along x-axis and y-axis. That is, we have to find the component of the vectors, let them be force or acceleration in two directions, along x-axis and along y-axis. Hence, represent AB in terms of unit vectors, that is I and J. Also verify that calculations of the components is correct. Now, to solve this question, see the figure. So, what we find, the horizontal component is 4 cos 60 degrees and the vertical component is 4 sin 60 degrees. And AB is a vector in two-dimensional plane. We can resolve it horizontally along AC or vertically along AD. So we find that AD AC component will be 4 cos 60, being the angle of inclination is 60 degrees. And the vertical component is 4 sin 60 degrees. Wherever it is sin 60, it should be taken as root 3 by 2. And wherever it is cos 60, it should be taken as 1 by 2. So here A is taken as origin in the figure. The component on x-axis is AC, that is 4 cos 60. So we multiply 4 into half. And component along y-axis is AD, that is 4 sin 60, that is 4 into, and we put the value of sin 60, that is root 3 by 2, 2 root 3. Hence, AB can be equal to 2i plus 2 root 3ij, 2 root 3j, where I and j are the unit vectors along x-axis and along y-axis. So the values of I and j we can estimate with the help of the coefficients of the numbers. So verification, what we do, we take the coefficient of I and square it. Then we take the coefficient of j, again we square it. Then after taking the squares, we add them and then the whole square root is taken and that will become 4. Now in the next example, one of the vector is given as 3i plus 4j. That is, k is not present. So k will be obviously 0. So b is equal to 7i plus 24j. Again, k is 0. Only vectors, unit vectors along x-axis and y-axis are given. The vectors having the same magnitude as b and parallel to a will be how much? So in order to solve this question, the required vector is c, that is cxi plus cyj, where I and j are the unit vectors along x-axis and y-axis. Cx is the component along x-axis and cy is the component along y-axis. Given that c is parallel to a, so cy over cx is equal to 4 by 3 by calculating the values. And modulus of c, that is magnitude of c, is equal to magnitude of b. Therefore, cx square plus cy square is equal to, it will be 7 square plus 24 square. And next will be, after calculations, we come to equation number 2, that is cx square plus cy square is equal to 625. And solving equation 1 and 2. In one it is given cy over cx, and in the second equation it is given cx square plus cy square equals 625. We have to just use basic algebra, that is a plus b whole square is equal to a square plus b square plus 2ab, or we can simply say that is cy is equal to 4cx over 3, and wherever it is cy, we will put 4cx whole square. So after the calculations, we will find that cx comes to be 15 and cy comes to be 20. So c becomes 15i plus 20j. There is an alternative method. We take the coefficients, we square them, then we add them and then take the square root. That comes to be 25. After that, unit vector in direction of A, that is given as 3i plus 4j over 5. Required vector will be 25 into, and that vector will be 3i plus 4j over 5. By calculation, we will cancel off 25 by 5. It will become 5, and that 5 is multiplied by 3i plus 4j, and the net result becomes 15I plus 20j. In the next question, we find a particle is displaced from position P1 to position P2. The coordinates of P1 are T212 meters, and for P2 the coordinates are 424, and we have to estimate the displacement of the particle. To solve the question, the initial position vector is R1, and we have taken 2I plus j plus 2k, because P1 point is 2, 1 and 2. So we will just apply I, j and k with these numbers. So it will become 2I, j plus 2k, and the final position is R2. And for R2, we will put the coordinates of P2. So we will write 4I plus 2j plus 4k. Now, displacement will be R2 minus R1, and that will be by putting the values of R2 and R1, the net value will become 2I plus j plus 2k. The point to remember is that I, j and k are the unit vectors along x-axis, the y-axis and the z-axis. Well, in the next question, we find that the resultant of the two vectors P and Q is perpendicular to P. Find the angle between P and Q. To solve this question, if the resultant makes an angle alpha with vector P, then tangent alpha, according to parallelogram law of vectors, tangent alpha will be estimated by Q sine theta over P plus Q cos theta. This is a formula which normally we derive from the parallelogram law of forces or the parallelogram law of vectors. Now alpha is given to us like in the question, it is perpendicular, means pi by 2, that is 90 degrees. So tan alpha, that is tan 90, that will be infinite. So P plus Q cos theta will be 0, or cos theta will be minus P over Q, and theta we can write in the inverse function, that is cos inverse P over Q. In the next question, a particle is moving eastwards with the velocity 5 meter per second in 10 seconds. So time is given and the velocity in the direction east is given. The velocity changes to 5 meter per second northwards. Calculate the average acceleration in this time. And now we can see the figure. The whole thing is given in the figure. And in the figure we find that west, east is given, north, south is given in the frame of reference. V1, V2 are the vectors. And we find that delta V, that is change in velocity. Change in velocity is V2 minus V1, and that is delta V. So we will use the formula V2 square plus V1 square minus 2V1 V2. This we have done with respect to the parallelogram law. And this is found to be after calculation and putting the values 5 root 2. Therefore, the average acceleration delta V by delta t, that is derivative of velocity with respect to time, we put up the values 5 root 2 divided by 10. Because it is given the variation is taking place in 10 seconds. So the net amount will come 1 over root 2 meters per second. We can rationalize the number also, but otherwise acceleration is 1 over root 2 meters per second square.